Okay, for number one, we're on part C now. Part A we did, part B we did, now we're doing part C. All right, part C says the polynomial s of x has degree 4, it has integer coefficients, and the coefficients of x4 is 1. All right, so I'm thinking this sort of looks like what we just did in part A and part B, but they're going to say s of A, s of B, s of C, s of D equals 2001. And I'm going to just write that down. They say where A, B, and C are distinct but not necessarily positive integers. So let me see if I can figure this out. Right? Just with understanding I just did A and B, and it's related to A and B in some way. All right? Go to the whiteboard, and I just finished off A and B, right? So let's do this over here. So this is still number one, and we're on part C now. And part C has two parts to it. All right? So again, I got to read it, and it says over here, find a polynomial, fourth degree. So I know it's a fourth degree polynomial. It's called P of x. They tell me the k is 1. I'll put this over here. And I'm going to say it's fourth degree. You know, it's going to be x minus a, x minus b. I don't know what these a's and b's are at this point, though. X minus c, and x minus d. All right? However, they told me that this thing evaluates to, I got to read it again. Let's see, the polynomial has a degree 4. But that's a degree 4 polynomial, by the way. It has integer coefficients, and the coefficients of x4 is 1. So I got that fits that criteria, by the way, right? It satisfies that s of A, s of B, s of C, s of D equals 2001. So I'm going to say over here that they, you know what, they didn't call it P, they called it S. Let me get my eraser out. Let me put that down for you. That's S, all right? So let me do what they said. They said S of A equals S of B equals S of C equals S of D, all right? And again, A, B, C, and D are distinct, but not necessarily positive integers. So they're integers, all right? So let me put this over. A, B, C, and D are integers. All right, but they're distinct. That means A does not equal B, does not equal C, does not equal D. They're all different, all right? But they say they should evaluate to 2001, all right? So let me write this down over here. So the polynomial now, for that to be the case, by the way, if you plug in S of A, it's got to be 2001. And what I know about this, if you plug it in, this would become 0. If you plug in B, this becomes 0, this becomes 0, that becomes 0 when you plug in the A, B, C, and D. So you get 2001. So I know my fourth degree polynomial now. S of x is equal to x minus A, x minus B, x minus C, x minus D, plus 2001. All right, let me keep reading it. Show there's no integer e such that SE equals 2018. All right, so I got to write this down now. So I got to write down S, there's going to be some integer E. E again is some integer. I have no idea what the integer is, by the way. But what would this look like? It would look like E minus A, E minus B, E minus C, E minus D. Let me repeat this. E, A, B, C, and D are integers. So this multiplies out to be an integer, and then I get 2001. And what did they say? This is going to be equal to 2018, right? Now I got to show there's no such integer that would do that. So again, I want to point out that A, B, C, and D are integers, and E is also an integer. So what I look at it looks like a factorization problem now. So E minus A, which is an integer, E minus B, which is an integer, E minus C, which is an integer, and E minus D, which is an integer. And what would you get over there? You would get 17. You would get 17. All right? Now, by the way, did I say 17? Let me just see if I said that right. Yes, 17. All right? So I'm looking at 17, and I want to kind of write down, because the 2001 minus 2018 is 17, I'm going to write down that these have to be integer factors. Integer, 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 integer. So then the question comes is, what would it have to be? Well, there'd have to be a 17 somewhere, because that's the only way to get 17. There'd be a 1, and a 1, and that would equal 17. What's the other possibility? Well, I mean, I could use negative integers too. I'll put that down for you. I guess I could put down like minus 17. I don't want to write every combination down, but I'm just kind of thinking about it. Minus 1, 1, and 1. That's 17, by the way. I guess you could do, like 17. I'm jumbling these up, by the way. Minus 1, and 1. That would equal 17. By the way, I'm not going to jumble these things up, but you could jumble those things up. I'm not saying the 17 is E minus A. It could be E minus C, but there's 4 factors there. You can jumble these. I'm just wondering what the possibilities, what it's going to look like, by the way. What else could it be? It could be 17. Well, I'm going to put minus 17 again. Don't the other possibility. Minus 1, minus 1, minus 1 is equal to 17. I want to remind you, though, this is about the only choices I come up with at this point, that 2 of the factors are negative. A little variety in that one, too. They could be all positive. 3 of them could be negative. 2 of them could be negative. But there has to be 3 factors of 1 into 17 because they're all integers, and they got to produce a 17 in the end. So I'm going to say, looking at it, no choice gives 4 distinct factors, all right? Now, what do I mean by 4 distinct factors over here? These can't be in agreement, and why is that? E is the same number, but A, B, C, and D all have to be different, so I would need 4 distinct factors. I don't have 4 distinct factors. Like over here, this doesn't fit the condition. I do not have 4 distinct factors over here. This doesn't hit that condition. I don't have 4 distinct factors. This over here, I don't have 4 distinct factors. What I mean by that, 3 of them agree here, 2 of them agree here, 2 agree here, and by the way, 3 agree here. None of them have 4. So I'm going to say there's no way to do this over here. So this one over here, this is part C, number 1. I just showed that this is not possible, given the condition that A, B, C, and D are distinct integers, and E is an integer. What do you mean by integer? It could be any integer, including it could be, it could be A, but if it were, it wouldn't be equal to, it could be B, but it wouldn't be equal to 17. It could be C, but it wouldn't be equal to 17. But I'm going to say E is an integer, and I'm going to say, if it's 17, if it's equal to A, B, C, and D, you're not going to get 17. But for any integer, this is just not possible. We're not getting 4 distinct factors, all right? So let's go to number 2 now, and we're still on part C, number 2, all right? So let's write the polynomial. I'm going to forget what the polynomial is. The polynomial is going to be S of x, and that was x minus A, x minus B, x minus C, x minus D, plus 2001. Okay? What'd they say? Find a number of ways of distinct integers A, B, and C can be chosen such that S0, I'll put this over here, such that S0, well, let's write down what S0 is. It's going to be minus A, minus B, minus C, minus D, plus 2001. Now, if you multiply that out, again, I want to remind you that A, B, C, and D are integers. They're not necessarily positive integers, by the way. But looking at the sign analysis over here, I'm just going to say it's A, B, C, D, plus 2000. Oh, this is S0, is 2001. All right? So I think I did okay there. And let me just read this. It's find the number of ways distinct integers, A, B, C, D, can be chosen so that S0 is 2007. Put this over here. I'm sorry, 2017. All right? So let's write this down over here. So it's going to be A, B, C, D equals, 16. All right? That's not so bad. All right? Now, I have to realize that, A, B, C, and D are integers, but their product is going to be 16. And I got to think about the ways of doing this over here. And thinking about it, and let me just read that again carefully about, find the number of ways. And again, I want to point out that A, B, C, and D are distinct integers. I can't use the same ones, all right? So I got to start thinking about this over here. And the way I'm going to think about it, always thinking is always difficult, by the way. I'm going to say, I don't know, maybe A is 8. And I'm going to put down 1, And I'm gonna put down, I can't put 1 down again, can I? But I'm gonna put down -1. And I have to put down -2 now. All right? Now, does that work out? It does. And by the way, you can jumble these up. What I mean by that is you could say 8, 1, -1, -2. You can put it in a different order if you want. But I'm looking for other distinct integers at this point. So I started with 8. Let me try 4 now. By the way, I'm thinking about this thing, and I got to get 16. And I'm going to say, I don't know, maybe 2. That gives me 8. I would need another 2, but I can't use 2. I'm going to use -2, and I'll use a -1. Does that give me 16? It does. All right, so 4, 2, -2, -1. Let's try another one. Let's try 4. Let's try -4. They're not the same. 4 and -4 are different. This is A, B, C, and D, by the way. All right, you can jumble them up if you want. All right, what do you get next? Well, that's going to give me 16. So now what are you going to do? You can see if I can do this, by the way. 1. I still got -16, -1. I have 4 distinct integers. It gives me 16. So I'm going to say, I think I've exhausted it. The problem with counting is sometimes you miss something, but I think I've done it. I think I've got the combinations here. And by the way, there's 3 of them. So it's going to say there's 3 combinations. All right, so I'm going to say over here, 3 combinations. Let me just read it, see if I got the thing, the reading right. It says, find number of ways distinct integers. Oh, you know what? They have another condition over here. I didn't see that. I want to see if I met that condition, because if I didn't, I got to rewrite it. Let's do the first one. And I want to see if I've done that. And I'm going to look at this one, see if I've done what they said. So I'm going to say 8. I am going to say 1. I am going to say -1 and -2. Let me see if I met the condition, by the way. I got the 8, got the 1, -1, -2, and I got the order right. So this is good. I got this is one of them, A, B, C, and D. And again, I didn't see that condition initially. Let me look at the second one and write that one down. 4. 2, -1, -2. Make sure I did that right. 4, 2, -1, -2. Does that give you 16 when you multiply them together? Yeah, it gives you 16. All right, let's do the next one. And I'm doing this one over here. The largest number there is 4. And then you can get 1, -1, and -4. And let's see if I did that. Yeah, that's good. So these are the numbers over here, all right? And I'm pretty sure that I'm exhausted that. I don't think there's any others. I'm going to say there's 3 of them. And we're done with problem number 1. This is part C, part 2, by the way. Thank you.